So we are going to continue with method to prepare our soluble salt, and this is the method number 2, in which we can make a soluble salt by taking an acid and alkali. They will react together and make finally at the end a dry salt, which is going to be a soluble salt. Okay. For this second method now, we are going to use a titration. Yes, Mariam. Mariam, is there any question? No, okay. Okay, so for this one, we are going to use titration method. Titration method we did in other file in detail, how we can use the burette, the conical flask, indicator, and all the stuff. So titration method we are going to use to mix the acid and alkali together to make a dry salt at the end. Yes, Luna?
Miss, as we revised before that preparing a soluble salt, the first one, we used an acid and insoluble base. So
Hmm.
I'm going to ask for this one, acid and alkali, are they both soluble? Are they
What does mean
insoluble?
by
If
alkali?
yeah, soluble in
Soluble.
water. Yeah, base soluble in water.
Okay, alkali means a soluble base. So now we are going to use a soluble base with acid. Okay, in the first method, it was acid and insoluble base, and we are doing the filtration method. Now we are using the acid and alkali because in the titration, they two have to dissolve with each other. So acid and soluble base alkali is going to react in case of the titration method. Okay, so after that, so how we can perform the titration? We did in previous class in detail. So now we'll just revise it again. So first of all, we are going to take conical flask in which we will add alkali. As I told you, maximum of the acid and alkali, they don't have any color. They are colorless. So if the reaction will happen, there will be no color change. We will not be able to see when the reaction is done. So we need to add some indicator to give starting color, and then when they react together they will change the color again, which will be indication that the reaction is done. Okay, so we are taking a known amount of alkali, let's say 25 centimeter cube, 20 centimeter cube, whatever, in conical flask, and then we are adding a few drops of indicator to give it a starting color. Indicator we can use any one of them is phenolphthalein indicator. We did few indicators in previous class as well. So when as soon as we add the phenolphthalein indicator, it will get some color. Okay. After that, now fill the acid solution in the burette. Till the top, it will be having reading till let's say 50 centimeter cube. Then take the same conical flask and put it under the burette. Open the tap from here. Slowly, slowly, few drops will keep adding. Keep shaking this conical flask as well so that you can see when the color is going to change. And then as soon as the color will change, just close the tab and you will, let's say here is the starting color is different. When it will react, the new color will be different. So color change will happen over here. Okay. Then stop the tab and note down the volume, how much is used. Let's say the starting was 50, here you have 30. It means what is the difference? The difference will tell you how much volume is used. Let's say 20 centimeter cube volume is used. Okay. Yes, Samreen, your question?
Yes, miss. Miss, in the titration that we do in an acid alkali titration, we perform a rough titration. So will we perform a rough titration here?
Yes, we're going to perform rough titration always. Okay, that is the basic rule of the titration, that you need to do rough titration, then repeat the titration 2, 3 times more. We said the rough titration is basically to see a rough idea when the color change is going to happen. For
Yes,
example, after use of 20 centimeter cube, let's say the color change is going to happen. If you don't do the rough titration, what will happen? You will keep adding few drops, few drops till 20 centimeter cube is used. It will take a lot of time. So rough
hmm.
titration means open the tap quickly, keep adding the solution quickly. Near 20, the color will change. It will give you a rough idea that 20 something is going to be your value. So when you're
Yeah.
going to perform the real titration, not the rough one, then till 15 centimeter cube, you can add fast, then make it slow.
We can, what we can do,
Drops,
we
few
can just
drops.
we can add
Hmm.
like the puree. So we can add from the puree one drop at a time.
Yes. From the burette, your choice. If you're going to open the tab slowly, you can add drop by drop. If you open this tab quick, full tab, it will keep adding fast. Okay. So rough
Okay.
titration means it is giving you idea when the color is changing. So to perform the real titration, you can add the first few mLs, the centimeter cubes like 15 or 18 quickly. Then add slowly, slowly so that you get real exact value of the volume that is going to change the color. So rough titration is going to save your time. Okay. Then repeat this titration, we said 2 to 3 times so that the final values that you are getting are close from each other, 0.1 difference only. That values you have to choose and then you have to take the average. Okay. Now, what we are going to do, this whole method is clear to you, right? The titration method. Now we have to do the same titration. First, we are doing again, let me just tell you again. First, we are taking the solution in the conical flask, right? Adding indicator. Then we are taking the acid in the burette, adding the acid, let's say 20 or something, and then it is going to give us the color change, and it means the titration is done. Now the problem is, if you're going to take this conical flask and collect the salt from here by evaporation or crystallization, this one has color. We don't need color in the salt. Color is impurity over here. Indicator is used to only see the idea when the color is going to change and when the titration will be done. But if we want the salt from this solution now, by let's say evaporation or whatever, we don't need color inside. So to do this, what we are going to do, we are going to perform the titration again. Yes, Jude, you want to say something?
Yes,
What
Miss,
we
I
can
just
do?
wanted to answer. It's
Yes, sure.
what we're going to do. We are going to repeat it again, but without, using the indicator because now we know the values, so we can do it again.
Yes, very good. So we are going to do the same titration now again without indicator. Because indicator was changing the color and giving us the volume. Now we got the volume that after 20, it will change the color. So it means 20 cm³ we have to add. So now we can take the base, the alkali in the conical flask without indicator, then add the acid. No color change will happen, just add 20 centimeter cube. That was the value you got. So that it can make the salt in this solution without color, the real salt without any impurity or color. So that's how we are going to repeat these steps, all the steps without indicator to get the colorless salt, the actual salt, without any impurity or indicator. Okay. So after repeating this without indicator, move to the step number 4. The step number 4 is transfer the solution from previous conical flask into this evaporating dish or evaporating basin. Then heat it partially to evaporate the water. Partially means slowly and somehow, not completely. Don't make the solution dry. Make the solution somehow saturated. So heat it partially and not very high flame. Okay. Solution will become more concentrated, or you can say somehow saturated. Thick solution will become over here. Then remove this dish or evaporating basin from the heat, no more heat, and then dry it at room temperature. Let it be cool down and it will dry the crystals. And after that, you can collect the crystals. You can wash them with water and dry them in with the help of filter paper. And then your whole method will be done. And that is going to be the soluble salt collection.
Miss,
Okay. Yes.
Miss,
Hmm.
for no, what I was gonna say, for the part of evaporation, is it the same as the first one with the preparating, like because we evaporate the solution and then we leave the crystal, so we evaporate only half and half will be evaporated
The same
naturally.
method, yes. Yes. So it's written over here as well. We are going to partially evaporate it, heat it, so that we can get a saturated solution. Okay. After getting the saturated solution, leave the crystals and decant the excess solution means remove the excess solution. If you have extra solution, just remove it and then just let it cool down and crystals will form at room temperature. Okay. So saturated solution we will leave so that remaining solution evaporate or just remove it physically. Okay. crystals will dry and we will get the final solution. Now, there is a reason that why we are, before I will tell you guys, can you explain and can you tell me if you have any idea why we are heating partially over here to make saturated
Miss,
solution? Why we are not completely heating to remove all the solution? Any idea?
Miss,
Uh,
Miss, can
Raise your hands only. Yes, Wafia?
no. Okay.
Miss, so to prevent, like, if we overheat the solution, then maybe the salt could like burn or something.
Okay, burn. Right. Yes, Jude?
Yes, miss. So as Afia said, if we overheat it or we heat it completely, it will still form crystals, but the crystals might be darker in color, and also they will be so small, and we want larger crystals. So if we leave it to evaporate slowly, it will, there will be larger crystals.
Okay, right. Yes, Umama. What's your
No,
point
it's
of?
the same one about small cluster and the large ones.
Okay, Samreen.
Once told us before that if we do not leave the water, that then it will, if you do not leave the water, it's like to prevent the decomposition of the salt.
Okay. Yes, Luna, your idea.
Miss, Wallah Lazim, all of them said the same thing. So
It's okay.
it's for the to obtain much larger and prettier crystals.
Hmm.
It's not about prettier, it's just obtaining salt. And for the decomposition of salt, because we don't want them
Hmm.
to be decayed and not able to use them in daily life. We want to use them and make use of them. We don't want to ruin them and make them
Right.
decompose. That's
Okay. So yes, basically we are heating it partially. First of all, two reasons are there. They can come in the exam for 2 marks. They can ask you what are the two reasons we are heating partially or leaving them to dry at room temperature. Number one, we are heating partially, we are evaporating partially so that there will be no decomposition of the crystals. There will be no breakdown of the crystals. Then we are leaving them at room temperature to evaporate the water so that we get the final crystals bigger in size, larger in size. So both reasons you can mention here. Partially heating so that there is no decomposition, leaving them at room temperature to become dry so that we can get bigger size crystals. Okay. Okay. Now we have one method to prepare insoluble salt. In the solubility rules table, we have seen that some of the salts will be insoluble, especially the silver and lead chlorides, barium, calcium, and lead sulfates, some of the insoluble carbonates, and we have most of the hydroxides, and carbonates, hydroxides are most of the time insoluble, except these. So to make these type of the salts which are insoluble, we have a separate method. This method is known as precipitation method, precipitation reaction. Why we say this precipitation reaction? Basically, precipitate is insoluble solid. To make insoluble solid, method is known as precipitation reaction. Okay, precipitate is something which is not soluble. It's a solid salt or insoluble salt in water. Okay, to make this precipitate, you need two reactants, and both reactants should be salt now. You're not taking any acid or alkali, okay, or any base. You're taking two salts to react together and make the salt that you want. So your first salt should be soluble. Second salt should be soluble as well to make one insoluble salt, and the second one will be soluble. So you need this one basically. Okay. For example, if you want to prepare the silver, let's go back to the table. Let's say I want to prepare the silver chloride, as the silver chloride is going to be insoluble salt, right? So I want to prepare silver chloride, which is insoluble salt. To make the silver chloride, I need two salts which are soluble now. One of the soluble salt will give the silver, and one of the soluble salt is going to give chloride. Getting the point? Any idea if you can tell me which two salts should I choose to make silver chloride, and both the starting salt should be soluble? One should have silver in the formula, one should have chloride in the formula. Raise your hands and give me your idea.
Miss, may I?
Yes, Luna.
Okay. So I'm guessing. Oh, wait, hold on. Oh no. I was about to say hydrochloric acid, but it won't work.
That is
It
an
won't
acid.
work.
We need two
But
soluble
one of
salts.
the
One of them have silver in the formula, one of them have chloride in the formula to react together and make insoluble silver chloride at the end. Okay, think about it again, Luna, and meanwhile we can have, yes, Wafia.
So, Miss, we could use silver sulfate maybe, and
One
something high
silver
on the.
sulfate maybe, okay. And
And for the next salt, we could use something that's more reactive than silver. So, potassium chloride.
potassium chloride, okay, fine. Okay, so if we use this pair, silver sulfate will give the silver, potassium chloride will give the chloride over here. Okay. And silver sulfate, if you come over here in the sulfates, most of them are soluble except these three. So yes, silver sulfate is going to be soluble salt. If you see the potassium chloride, then if you come over here in the chlorides, all the chlorides are soluble except these two. So yes, potassium chloride is also a soluble salt. By using this pair, we will be able to make silver chloride. What will be the second product in that case? Yes, Wafia. Silver
Potassium
chloride
sulfate.
and potassium sulfate. Yes. Yes, Luna.
disconnect. Okay, I thought about it. So silver nitrate, if possible.
Silver nitrate. Yes, it will work and it's soluble.
Okay, nitrate plus ammonium chloride.
Ammonium chloride. Yes, all ammoniums are soluble. Yes, ammonium chloride can work as well. Right.
So they work,
So this
right?
way we can
Silver chloride
here.
plus ammonium sulfate.
Right. Yes, Samri, you want to share again?
Miss, we can use iron sulfate and potassium chloride.
Iron sulfate. Yes, all the sulfates are soluble. So it will iron sulfate.
Miss, iron
Iron
sulfate.
sulfate will not give silver, not give chlorine. Chloride.
Wait, miss.
So choose
Miss,
a
I don't.
sulfate maybe which has silver and then any metal with chloride. Like this, a pair.
So miss, like silver sulfate, and then there can be sodium chloride, like that.
Right. Silver sulfate is fine because it will give silver. So it should have silver at the start. Second name you can change. And this one
So it
should
can
have chloride at the end and first name you can change. Yes, so silver sulfate and sodium chloride will work as well. Okay, let's go back to the file. So basically we are going to choose a pair, one for soluble salt 1 and other is soluble salt 2, and then we'll get insoluble salt and a soluble salt at the end. Here you will notice one thing. Let's say this has the formula AB, this has the formula CD. What will happen? They will switch. A will come with the D, B will go with the C, right? We said that when they switch their position, that is replacement reaction or substitution reaction. Here the
Or
B is going with the C, means one-time replacement. A is going with the D, means double replacement. Two times they are replacing. So this kind of the reaction where we have double replacement, we also have a name for this, double decomposition reaction. What does mean by double
Miss?
decomposition reaction? Here is the definition. It means it's a type of reaction in which two reactants interchange their positions to make two new compounds. Here the A is also changing the position with the D. B is changing the position with the C. Okay. So two of the reactants both interchange their position. then we say them double decomposition reaction. After reacting them, the insoluble salt and soluble salt are now both in the same beaker. We have to separate them as well. So after reaction, because the insoluble salt is going to be precipitate, not dissolving in this one, so we can easily use filtration method to separate it. Okay, use the filtration to separate the precipitates, and then you have to wash with the distilled water to remove the reactants. Reactant means if there is any soluble salt present from the reactant side, it will remove, and this soluble salt 3 will remove as well. Okay, so we just need the crystals, which is insoluble salt over here. And then you have to, after washing, you can let it to dry. Leave it in the room temperature so that it will dry and you will collect it. Okay, so this method is very common to prepare the silver and lead 2 salts, which are insoluble, and to make them we can use the nitrates of them, because nitrates are all soluble. We can easily use the nitrates. Okay, now let's take more example. Without looking at the solution, you can use the solubility file only, solubility table for the rules. If we want to prepare the copper 2 sulfate, copper 2 sulfate is a soluble salt or insoluble salt. Which method we can use to make copper 2 sulfate? Copper 2 sulfate, you can use the table to see about the copper 2 sulfate for now, but in exam you need to remember it and make an idea by yourself. Is it soluble or insoluble? First of all, is it soluble or insoluble? Yes, Wafia.
Mm.
It's soluble, miss.
So which method we can use? What do you
Miss,
say?
we could use the acid-base reaction,
Okay.
and we could also use the metal and acid reaction.
Right. So we can use both the soluble salt methods because it is one of the soluble salt, right? Okay. Yes, Luna, your suggestion?
Miss, I was about to say we could use if we were given the examples, which is the normal, which is the acid and insoluble alkali, and for the titration, which is using the titration, which is acid and soluble alkali. Oh, the
Okay.
before one was
Okay.
so the
Yes,
same.
Amreen.
Miss, we can make there's these 2 methods. Like the first method can be using an insoluble base with an acid. That can
Right.
be, we can use it using a titration.
Okay, right. Okay, yes. So to prepare the soluble salt, copper 2 sulfate is one of the soluble salt. To make its dry sample, we can use any method from 2. So they are choosing one of them, that's fine. So they are choosing the method in which they are taking insoluble base with acid, the very first method. Okay. So for this, whatever material is needed, it's written we need the dilute sulfuric acid, which will provide sulfate. Okay, and then we are using the copper 2 oxide, which will provide copper over here. Okay, so they said insoluble base, so copper 2 oxide is going to be insoluble base over here. Then using the spatula rod to mix it, spatula to add the salt over here, the copper 2 oxide over here, and glass rod to mix it. Measuring cylinder, 100 centimeter cube beaker, Bunsen burner, tripod, gas, heat-proof mat to heat it, filter funnel. All this material in your ATP exam, it will be given to you, but they will ask you, some of the material will be missing. They will ask you whatever material you need to do this reaction and write the steps or make a diagram as well. Okay. So in the diagram, what we can make, we can take the tripod stand. There will be Bunsen burner. We can put the beaker. Inside the beaker, we are going to first of all add the dilute acid, heat it, and then add the insoluble base inside so that they can react. By using the glass rod, we have to mix the solution continuously so that it will react properly. And as soon as it will react, and you will be just going to do the filtration method after that, because what will happen, why we are doing the filtration step over here? Any idea?
Miss, may I answer, or will
Raise
you
your
take
hands.
for?
Jude.
Yes, miss. So as we discussed earlier, like in other classes, we add the base in excess because if the acid doesn't have enough base to react with, it will be dangerous for it to remain. So there's excess base, so it's insoluble. So we need to remove it from the solution by filtration.
Right. As we said that we are going to add the excess base so that it can react with all the acid over here. Okay. So excess base and base is insoluble that we are adding. Means it will stay in the form of solid. So that insoluble base reactant we have to separate from the solution by filtration method. Okay. There was one more point that we did in previous class that we are adding excess base. We are not adding excess acid. Any idea why we are adding excess base, not acid? What will happen if the acid will be in excess? What can be the dangerous thing at the end of the reaction? Yes, Lona.
This acids are well known for their specifically potassium, sodium, and those are very reactive and cause explosive reactions. So it is very dangerous to leave them bare with a base, and if it was in axis, then the base will be neutralized, but the acid is still there, and it will cause an explosive reaction. And yeah.
Explosive reaction. Somehow closer answer, but I need more exact answer. Anyone else can try? Samreen.
Because, miss, any unreacted acid will become dangerously concentrated during the
Hmm.
processes of crystallization and filtration.
Right. Yes, Wafia and Jude. You both will answer as well.
Miss, it was the same thing. I was gonna say that if there's any acid that's in excess that has not reacted completely, then it would become dangerously concentrated
Hmm.
in the evaporation and crystallization processes because it'll be heated up anyway, which just
Hmm.
increases its reactivity somehow.
Okay. Yes, Jude. Your
Yes,
point of
miss.
view?
It's just the same thing because if we imagine that we put, the base that is in less amount than the acid, so the acid will remain in the solution, and when it's heated for the crystals to be formed, it will be concentrated and it will be dangerous.
Right. Okay, so that is the reason we are using the excess base, not the acid, because excess acid, if it will remain till the end after evaporation step, it will become highly dangerous and concentrated. Okay, so after doing the filtration step, now we will move toward the evaporation step. Again, we have to put the solution in the evaporating dish or basin. We have to heat it to make the concentrated or saturated solution so that then we can just leave the solution at room temperature to dry and get the bigger size crystals. Okay. In the method, which steps you can write, you have to follow the same pattern to write the steps. That first we are adding, let's say, 50 centimeter cube of the acid into the beaker and heating it gently. Then we are slowly adding into the hot acid the copper 2 oxide, which is the base, and we are going to add it little excess. Acid amount you're going to make it fix, maybe 50, 40, whatever you want. So you're going to mention the amount of acid. It is fixed. Base, you will say it is going to be in excess. Okay. So until the base will stop dissolving and suspension will start forming means now the reaction is done. No more acid is reacting with the base. So you will keep adding the base till that point. Then you will filter the mixture and then you will just add it to the evaporating basin or dish and then gently heat the solution in a water bath to remove the water to make a saturated solution. After making the how you can check the saturated solution? We did this in one of the lesson as well. Anyone can tell me this point? Raise your hand.
Miss, I have a
How we
question.
can? Yes, your question.
Miss, like it may be not related to your question, but Miss, why aren't bases? I don't specify like insoluble bases. I want bases in general.
Hmm.
Why
Okay.
aren't they like acid? Like, what is difference
Yes, Miss, I
between
had
them?
the same question. Why are we just aware for the acids, not for the bases?
No, again, Luna, your question is?
Miss, why are we aware from the acid than the base? Like base, isn't it also dangerous?
No,
Like,
the base is also dangerous if it is highly concentrated, but less than acid. Okay, it will be corrosive only. It will give the skin somehow burning and some damage as well, but not like acid. Acid is more dangerous than base. Okay, even with the base, when we are working with the base, we have to be very careful. But in terms of the acid, it is more dangerous than the base. Both are, in both, we have to be very careful when we are performing the experiment. Okay, bases when they are like normal, and if somehow they spill on your hand, fine. But if they are concentrated bases, they are going to be highly dangerous as well, but less than
so Miss,
acid. Okay.
if an acid spilled on our skin, then
Acid, if
corrosive
you have
reaction
acid
will
even in
happen.
the very diluted form, it will burn the hand. Okay. But base is dangerous
Miss,
when it is little concentrated, not the
Miss, does
diluted
it
form.
really,
Hmm.
Miss, does it really because of the proton transfer and the pH values?
Because of the proton transfer is as well, but that is its nature and property to be a dangerous thing. Like,
Hmm.
not all the bases are safe, some bases are very dangerous as well. Okay, so it's their property to become safe or dangerous. Okay, so I was asking this question, and yes, Umama raised hand. Yes, Umama. How we can check if the solution is
Yes.
saturated?
I was saying that we can dip a glass rod, and if we don't have a glass rod, we can use any spoon, the other side of the spoon, and we will dip it. And
Hmm.
after some seconds, there will be crystal formed.
Okay. On the glass rod. Okay. Yes,
Yes.
Wafia.
Miss, I was gonna say the same thing that you could use a glass rod or the backside of a metal spoon. And when you know, take it out of the solution, then it has like small crystals forming on the surface of the
Hmm.
rod or the spoon,
Right.
whatever.
Hmm. So
Miss,
yes, we can dip the glass rod in the solution. And if you see some of the crystals on the rod, it means the solution is now saturated. That is the indication of having a saturated solution. Okay. And then we can just follow the other steps and we can finish the reaction.
Miss,
Okay. Yes. Is there anyone having question?
just no, Miss, I want to relate this topic. Miss, don't we
Hmm.
also use it in crystallization, where we dip the glass rod
Yes.
to the
And
crystals?
in that case, we are also checking if the solution is saturated. It's ready to make crystals. Why we
Mm.
are checking this? We are checking if the solution is now ready to make crystals by dipping a rod in the solution and checking the crystals on the rod. Okay. And here the same reason is written when you are going to write any experiment in your ATP exam. It is very important to follow all the steps first. You have to write a good title, or maybe the title will be given to you. For example, that your aim is to make a dry sample of the salt. Then mention that whatever reactants you are using, what is your material, make one or two diagrams as well if they're asking about the diagram. And after that method, few points very clearly, no long paragraphs, to the point answer. Okay, some points in the method you can mention. In the practical tip or whatever thing we should be careful about, at least one or two point that we should be careful while using this can be the dangerous thing during the experiment. Whatever you know about this, one or two point you have to add about this as well. For example, over here, if we don't add base in excess, there is going to be acid, highly concentrated at the end of the reaction during after evaporation and crystallization stages. So that is going to be very dangerous. So this thing we should be careful while doing the experiment. And then in the result, you have to clearly mention with the heading what is going to be the final result. And your result is going to be, you are going to get large size crystals. And for copper 2 sulfate, we know they are going to be bright blue in color. So if you know the color, you can mention it. If you don't know the colors, just mention whatever is going to be the final product.